December 7th, 1941, Pearl Harbor, Hawaii. Commander Mochitsura Hashimoto stood in the conning tower of his midget submarine I-162, watching through his periscope as American battleships burned in the harbor ahead. The surprise attack had succeeded beyond anyone's expectations. Japan's submarine force, the finest in the world, had proven its worth. Silent, invisible, deadly, the underwater warriors of the Imperial Japanese Navy believed they possessed an insurmountable advantage in the Pacific War that was just beginning. What Commander Hashimoto and every other Japanese submarine captain didn't know was that American scientists had already developed a technology that would turn their silent hunters into hunted prey. A system so revolutionary that it could detect a submarine's presence from thousands of yards away, track its movements through solid water, and guide depth charges to within feet of their target, all without ever seeing the submarine. Within 3 years, this technology would help send 130 Japanese submarines to the bottom of the Pacific. By war's end, Japan would lose nearly 80% of its entire submarine fleet, the highest loss rate of any major submarine force in history. Not through superior Japanese tactics being defeated, but through a fundamental revolution in warfare that made invisibility meaningless. This is the story of sonar, the technology that allowed American destroyers to hunt submarines in total darkness, in storms, in the deepest ocean trenches. How sound waves became more deadly than torpedoes, and how Japanese submarine commanders, trained in the art of silent running and stealth, discovered too late that the Americans could hear a submarine's heartbeat from a mile away. The Imperial Japanese Navy entered World War II with the most advanced submarine fleet in the world. This wasn't propaganda, it was objective reality that American naval intelligence acknowledged with grudging respect. Japan's Type 95 torpedo was the most sophisticated in any Navy's arsenal. Oxygen-propelled instead of the compressed air systems other nations used, it left no telltale bubble trail. It could travel 9,000 meters at 49 knots, nearly twice the range of American torpedoes. Most importantly, its oxygen propulsion made it nearly impossible to detect until impact. The long-lance torpedo, deployed on Japanese submarines and surface ships, was even more fearsome. At 24 inches in diameter and carrying a 1,080-pound warhead, it could sink a cruiser with a single hit. American naval officers who survived long-lance attacks described them as appearing from nowhere, no warning, no wake, just sudden catastrophic explosions. Japanese submarine designs themselves represented cutting-edge naval architecture. The I-400 class submarine, the largest built by any nation until the 1,960 seconds, displaced 6,500 tons and could carry 3 attack aircraft in a watertight hangar. The Type B submarines had ranges exceeding 14,000 nautical miles. They could reach the American West Coast, conduct operations, and return to Japan without refueling. Japanese submarine doctrine emphasized offensive operations, while Germany used submarines primarily against merchant shipping and Britain used them for blockade and reconnaissance. Japan deployed submarines as fleet weapons, fast attack boats that would ambush American carriers and battleships, turn the tide of surface engagements, and project power across the vast Pacific. Commander Mochitsura Hashimoto, who would later command the submarine that sank the USS Indianapolis, exemplified Japanese submarine excellence. Trained at the Imperial Japanese Naval Academy, he had studied German U-boat tactics, American anti-submarine warfare doctrine, and had personally developed attack approaches that maximized the long-lance torpedo's advantages. "We believed ourselves invisible," Hashimoto would later write in his memoirs. "Our submarines were the quietest in the world. Our torpedoes left no trace. Our crews were trained to operate in absolute silence for days at a time. We could approach to within 1,000 meters of enemy warships without detection. The Americans, we believed, were fighting blind. This confidence was reinforced by early war successes. In December 1941 and January 1942, Japanese submarines sank multiple American vessels off the West Coast. They shelled oil refineries in California, causing panic along the entire Pacific seaboard. They operated with apparent impunity in waters the U.S. Navy considered its own. Lieutenant Commander Zenji Orita, commanding the submarine 177, conducted surveillance off Pearl Harbor in early 1942, remaining submerged within sight of the American base for 3 days. "We could see destroyers passing directly overhead," he recorded. "Their crews had no idea we were there. It confirmed everything we believed about our superiority in submarine warfare." Japanese submariners underwent brutal training that emphasized endurance, silence, and aggression. They practiced ultra-quiet operations where every crew member moved in stocking feet, spoke only in whispers, and all non-essential machinery was shut down. They could maintain this state for 48 hours or more, making their submarines nearly undetectable by the hydrophones underwater listening devices that other navies used. The Japanese had also studied American anti-submarine tactics extensively. They knew the U.S. Navy used hydrophones to listen for submarine engine noise. They knew American destroyers carried depth charges, barrel-shaped explosives that would sink to preset depths before detonating. Japanese doctrine taught submariners to dive deep, run silent, and wait out attacks. Depth charges, they believed, were weapons of desperation, explosive fishing that rarely hit anything. The Americans would drop depth charges randomly, Commander Takeo Kudo of I-36 explained in a 1942 training lecture to new submarine officers. "They cannot see us. They cannot hear us when we run silent. They drop explosives hoping to get lucky. It is not warfare, it is gambling, and we control the odds." This supremely confident assessment was about to be shattered by physics. What Japanese submarine commanders didn't know was that American scientists hadn't been trying to hear submarines at all. They had developed a way to see them with sound. The principle behind sonar sound navigation and ranging was theoretically simple, but practically revolutionary. Instead of passively listening for submarine noise, an active sonar system transmitted powerful sound pulses through water and listened for echoes. When sound waves struck a solid object like a submarine hull, they reflected back to the source. By measuring the time between transmission and echo return, operators could calculate exact distance. By analyzing the echo's direction, they could determine bearing. By tracking changes over time, they could plot course and speed. Water, it turned out, was an excellent conductor of sound, much better than air. A sound pulse could travel for miles through seawater, penetrate to depths of thousands of feet, and return detailed information about everything it encountered. The technology had been developed during World War I, but remained primitive and unreliable. Between the wars, the U.S. Navy's research laboratories, particularly the Naval Research Laboratory in Washington and the University of California Division of War Research, had refined sonar into a practical weapons system. By 1941, American destroyers were being equipped with the QC sonar system. A transducer mounted in the ship's hull could transmit and receive sound pulses. Operators wearing headphones would listen for echoes, measuring their strength and timing. The system could detect a submarine at ranges up to 2,500 yards in ideal conditions over a mile away. More importantly, sonar worked in conditions where visual detection was impossible. At night, in storms, in fog, or at depths below periscope range, sonar could find submarines that were otherwise invisible. It transformed anti-submarine warfare from desperate guessing into precise hunting. The early systems had significant limitations. Water temperature layers could deflect sound waves, creating shadow zones where submarines could hide. Biological noise, schools of fish, whales, even shrimp could create false contacts. Operators required extensive training to distinguish submarine echoes from background noise. The technology was still imperfect. But it was improving rapidly, and Japanese submarine commanders had no idea it existed. The first Japanese submarine to encounter American sonar was I-73, commanded by Lieutenant Commander Takayasu Kinashi. On January 11, 1942, I-73 was patrolling off Midway Island, preparing to bombard the American installation when the destroyer USS Gridley detected something unusual. The Gridley's sonar operator, Seaman First Class Robert Matthews, had just completed advanced sonar training at the Fleet Sound School in Key West. He was conducting a routine sweep when his headphones registered a clear echo at 1,800 yards, bearing 045 degrees relative. "Contact," Matthews reported to the bridge. "Submarine bearing 045, range 1800 yards, moving left to right." The Gridley's captain, Commander Lawrence Dubose, had been trained in the new anti-submarine doctrine. Instead of dropping random depth charges, he used sonar to track the contact precisely, adjusting course to maintain contact as the submarine maneuvered. In I-73's control room, Commander Kinashi was completely unaware he had been detected. His submarine was running submerged at 150 feet, silent running procedures in effect. By every measure of Japanese submarine doctrine, he was invisible. "Increase speed to 4 knots, Kinashi ordered, beginning his approach to the bombardment position. "Maintain depth. Prepare forward tubes for..." The first depth charge exploded 30 feet above I-73's hull. The detonation was close enough that the shockwave buckled plates, shattered gauges, and knocked every man in the control room off his feet. "Emergency dive," Kinashi shouted. "All ahead full. Take her to 250 feet. More depth charges followed, each one closer than the last. The Gridley's sonar maintained constant contact, guiding each attack run with precision that seemed impossible to the Japanese crew. For 40 minutes, depth charges hammered I-73 as Kinashi tried every evasion tactic in the manual course changes, speed variations, crash dives to deeper water. Nothing worked. The American destroyer followed every maneuver as if it could see through solid water. At 250 feet depth, with hydraulic lines ruptured, batteries cracked, and releasing chlorine gas, and the hull groaning under pressure, Kinashi made the desperate decision to surface and fight with his deck gun. It was suicide, but staying submerged meant certain death. I-73 broke surface in a fountain of spray. Kinashi's gun crew managed to fire 3 rounds before the Gridley's 5-inch guns opened fire. Within 3 minutes, I-73 was sinking. Kinashi and 59 of his crew went down with their boat. 15 survivors were pulled from the water by the Gridley. The captured Japanese submariners were interrogated extensively. Their testimony revealed something that shocked American intelligence. The Japanese had no idea what sonar was. "How did you find us?" one captured officer asked repeatedly. "We were completely silent, no machinery running except minimum life support. How did you know where we were?" When interrogators explained active sonar, the Japanese prisoners initially refused to believe it. One petty officer insisted it was impossible to detect a submerged submarine without seeing it or hearing machinery noise. The concept of using sound pulses as a detection system was outside their understanding of submarine warfare. This intelligence finding was immediately classified at the highest level. If Japanese submariners didn't know about sonar, American commanders wanted to keep it that way as long as possible. But the secret couldn't last. Too many submarines were dying. Between January and June 1942, American destroyers and destroyer escorts sank 12 Japanese submarines using sonar-directed attacks. Each sinking followed the same pattern. submarines running silent at depth, completely confident in their invisibility, suddenly subjected to depth charge attacks of uncanny precision. Japanese submarine force headquarters began receiving disturbing reports from surviving boats. Commanders described being tracked through radical maneuvers, pursued through depth changes, and attacked with accuracy that suggested the Americans possessed some form of underwater detection beyond anything in Japanese technology. Commander Hashimoto, after barely surviving a depth charge attack by the destroyer USS Patterson in March 1942, filed a detailed report. The enemy maintained contact through all evasion attempts. Silent running provided no protection. Deep diving, we reached 290 feet, did not break contact. The enemy knew our exact position at all times. Conclusion: Americans possess unknown detection technology. Japanese naval intelligence analyzed these reports with growing alarm. They understood hydrophone technology, passive listening for machinery noise. They had hydrophones themselves. But these attacks were different. American destroyers were finding submarines that were mechanically silent, tracking them with impossible precision, and prosecuting attacks that achieved kill rates far beyond what random depth charge patterns should produce. By mid-1942, Japanese submarine doctrine began to change. New orders emphasized deeper diving depths, more radical evasion maneuvers, and shorter patrol times in American-controlled waters. But these were responses to an unknown threat, modifications to tactics without understanding what they were defending against. The Japanese still didn't know about sonar. The turning point in the Pacific Submarine War came with the introduction of improved American sonar systems and the massive expansion of destroyer escort production. The QC sonar system was upgraded to the QGB series, which offered better range, more precise bearing calculation, and improved discrimination between real contacts and biological noise. Operators became more skilled at interpreting returns, distinguishing submarine echoes from thermal layers or schools of fish. More importantly, America's industrial capacity flooded the Pacific with submarine hunters. Destroyer escorts smaller, cheaper, and faster to build than fleet destroyers rolled off American shipyards at a rate Japan couldn't begin to match. Each destroyer escort carried sonar and depth charges. Each one was a dedicated submarine killer. By 1943, American anti-submarine hunter-killer groups were patrolling known Japanese submarine transit routes with overlapping sonar coverage. A Japanese submarine attempting to cross from Truk to the Solomon Islands might encounter 6 different sonar-equipped vessels during its transit. The odds of detection approached certainty. Lieutenant Commander Samuel Eliot Morrison, serving as a naval historian aboard the destroyer escort USS England, documented one particularly devastating patrol in May 1944. In just 12 days, the England sank 6 Japanese submarines using sonar-directed attacks. Each engagement followed the same pattern: sonar contact at long range, systematic tracking despite evasion attempts, depth charge attack with precision that gave submarines no chance to escape. The Japanese submarines fought bravely, Morrison wrote, but they were fighting blind against an enemy who could see them perfectly. It wasn't war, it was execution. The I-16, commanded by Lieutenant Commander Yoshitaka Takeuchi, provided a detailed account of what submarine warfare had become for the Japanese. Takeuchi's boat was conducting reconnaissance near Guadalcanal in August 1943 when sonar detected it at 2,000 yards. "We heard the transmission pulse," Takeuchi later testified after his capture. "A mechanical pinging sound that echoed through the hull. We didn't understand what it meant." Then, the depth charges began. We dove to 350 feet beyond our designed maximum depth. The enemy followed. We cut all power, drifted in total silence. The enemy maintained contact. We tried to hide in a thermal layer. The enemy found us. We attempted to sprint away at maximum speed. The enemy tracked us perfectly. After 4 hours of this, our batteries were exhausted, hull integrity was compromised, and we had no choice but to surface. The I-16 surfaced and was immediately destroyed by gunfire. Takeuchi and 7 others survived to be picked up by American vessels. His interrogation revealed the psychological impact of fighting an invisible enemy with an unstoppable weapon. We could do nothing right, Takeuchi explained. Every tactic we had trained for was useless. Silent running didn't help. Deep diving didn't help. Speed didn't help. We were blind men fighting someone who could see perfectly. Every time we heard that pinging sound, we knew death was coming, and we were powerless to prevent it. By 1944, Japanese submarine operations had effectively ceased in many areas of the Pacific. Not because Japan had run out of submarines or torpedoes, but because submarine commanders knew that entering certain waters was suicide. The Americans' mysterious detection technology, Japanese intelligence, had finally confirmed it was some form of active echolocation system had made traditional submarine warfare impossible. The psychological warfare aspect was as devastating as the physical destruction. Japanese submariners began to dread the sound of active sonar pings echoing through their hulls. That sound meant they had been found, that depth charges were coming, that evasion was likely futile. The stress of knowing you were being hunted by an enemy who could see through water caused breakdowns in crew discipline and morale. Survivors reported boats where crew members refused to go on patrol, where captains became paranoid and unstable, where the psychological pressure of fighting an invisible, omniscient enemy broke men's minds before depth charges broke their hulls. The Japanese Navy's own research into active sonar technology began far too late. By the time they understood what they were facing, American industrial capacity had produced thousands of sonar systems and trained tens of thousands of operators. Japanese attempts to develop equivalent technology foundered on lack of resources, lack of manufacturing capacity, and lack of time. Commander Mochitsura Hashimoto, who survived the war, later wrote with brutal honesty about Japan's submarine force failure. "We entered the war with the best submarines, the best torpedoes, the best trained crews. We lost because we were fighting 20th century warfare with 19th century tactics. We believed invisibility was enough. The Americans made invisibility meaningless. Sound became sight, and we were blind men in a world that could see perfectly." The technology gap widened further with each month of the war. American sonar systems improved continuously. The QHB series, introduced in 1944, could detect submarines at ranges exceeding 4,000 yards over 2 miles. Processing improvements allowed operators to determine not just range and bearing, but depth and even submarine type based on echo characteristics. Submarine commanders learned to identify individual Japanese submarine classes by their acoustic signatures. The large I-400 class boats produced distinctly different echoes than the smaller RO-class submarines. This allowed American destroyers to prioritize targets. If sonar indicated a large fleet submarine, multiple vessels would converge for the kill. The USS Batfish exemplified the devastating effectiveness of this technology. During one patrol in February 1945, the submarine, ironically hunting other submarines using its own sonar, sank 3 Japanese submarines in 4 days. Each was detected by sonar, tracked to attack position, and destroyed with torpedoes before the Japanese boats even knew an American submarine was present. The addition of airborne sonar sonobuoys dropped from patrol aircraft extended American detection capabilities even further. A Japanese submarine that successfully evaded destroyer sonar might find itself detected by sonobuoys from a patrolling PBY Catalina flying boat, which would then direct surface vessels to the contact. Japanese submarines attempting to transit from home waters to operational areas had to run a gauntlet of overlapping sonar coverage that made successful passage increasingly unlikely. By late 1944, Japanese submarine operational availability had dropped below 30%, not because boats were damaged or lacking supplies, but because commanders knew that leaving port meant probable death. The final statistics of the Pacific Submarine War tell a story of technological dominance translating into strategic victory. Japan began the war with 63 fleet submarines. During the war, they built an additional 126 submarines of all types, for a total of 189. Of these, 130 were sunk, a loss rate of 68.8%. When factoring in submarines damaged beyond repair or scuttled, the effective loss rate exceeded 75%. By comparison, the United States lost 52 submarines out of 288, deployed an 18% loss rate. American submarines, equipped with both passive sonar for hunting and active sonar for evasion, could detect Japanese hunters before being detected themselves. The technology that made Japanese submarines vulnerable protected American submarines. More significantly, the submarines Japan lost represented its best crews and commanders. Submarine training took years. Each experienced commander lost meant dozens of successful operations that would never happen, hundreds of tons of shipping that would reach American ports, and intelligence about American fleet movements that Japan would never possess. The submarine campaign Japan had expected to be decisive, strangling American supply lines, sinking carriers, terrorizing the West Coast, instead became a bloodbath that accomplished virtually nothing, while costing irreplaceable resources. American destroyers and destroyer escorts accounted for approximately 70 Japanese submarine kills. Another 30 were sunk by submarines, 15 by aircraft, and the remainder through accidents, mines, or scuttling. Nearly every surface vessel kill involved sonar detection as the critical enabling technology. The psychological reports from captured Japanese submariners revealed the complete breakdown of confidence that sonar had caused. Pre-war Japanese submarine doctrine emphasized aggressive attacks on high-value targets, carriers, battleships, heavy cruisers. By 1944, surviving submarine commanders were avoiding combat entirely, using their boats purely for supply runs to isolated garrisons. This represented total failure of strategic doctrine. Japan had built an offensive submarine force intended to win battles. It ended the war running supplies to bypassed islands because its submarines couldn't survive in combat zones where American sonar was present. Several captured Japanese submarine officers, when shown American sonar equipment after the war, broke down emotionally. One commander, whose name was withheld from post-war reports, stated, "If we had known this existed, we would have designed our entire submarine force differently. We optimized for silence. You made silence worthless. We should have optimized for depth, speed, or countermeasures. But we didn't know. We were fighting an enemy who could see, and we never knew we were blind." The technological lessons learned from sonar development extended far beyond submarine warfare. Active sonar principles informed post-war development of underwater mapping, marine biology research, and commercial fishing. The signal processing techniques developed to distinguish submarine echoes from background noise became foundational to radar development, medical ultrasound, and eventually digital signal processing. But the immediate impact was strategic. Sonar transformed the Pacific from an ocean where Japanese submarines posed a serious threat into a killing ground where Japanese submarines died in numbers that made their operational deployment strategically pointless. The parallels to the Sherman tank story are striking. Just as German tanks were individually superior but overwhelmed by American production and systematic advantages, Japanese submarines were technically excellent but defeated by American technology that changed the fundamental rules of warfare. Quality of individual platforms, whether tanks or submarines, became irrelevant when the opponent possessed systematic advantages that negated quality. German tanks couldn't exploit superiority when facing 10 Shermans. Japanese submarines couldn't exploit stealth when facing enemies who could see through water. In both cases, American victory came not from building better individual weapons, but from building better systems. Production systems for tanks, detection systems for submarines that made enemy advantages meaningless. Commander Hashimoto, in his post-war memoirs, included a passage that captured this realization. We believed submarine warfare was about individual skill, crew training, and ship design. The Americans understood it was about detection systems, coordinated tactics, and industrial capacity. They built thousands of sonar sets, while we perfected silent running. They trained tens of thousands of operators, while we trained hundreds of submarine commanders. When the war began, we had the advantage. When it ended, they had destroyed us systematically, almost mechanically, using technology we didn't know existed until it was killing us. The irony was profound. Japan had studied American military weaknesses extensively before Pearl Harbor. They knew American industrial capacity, but believed Japanese fighting spirit and tactical excellence would overcome material advantages. They were right about American production, but wrong about it mattering. Sonar represented the ultimate expression of American warfare, not individual heroics or tactical brilliance, but systematic application of technology at industrial scale. One sonar set was just a tool. 10,000 sonar sets, deployed on thousands of ships, operated by trained crews, supported by sophisticated doctrine, became an unbeatable system. Japanese submarines never knew American destroyers could see them 100 feet underwater with sound alone. By the time they understood what they faced, 130 submarines had already been sent to the bottom, their crews never knowing why their training and tactics had failed so completely. The submarine war in the Pacific was decided not by courage, not by crew skill, not by torpedo technology, but by physics and production. Sound waves traveling through water at 4,900 feet per second, detected by thousands of transducers, analyzed by thousands of trained operators, proved more deadly than all the long-lance torpedoes Japan ever built. In the final accounting, Japanese submarines sank approximately 184 merchant ships, totaling 907,000 tons, and damaged but did not sink the carrier USS Saratoga twice and the battleship USS North Carolina once. For this, Japan lost 130 submarines and over 10,000 trained submariners. American submarines, protected by their own sonar and hunting with it, sank 1,314. Japanese merchant ships, totaling 5.3 million tons, plus 1 battleship, 8 aircraft carriers, and 11 cruisers. The disparity was overwhelming. Technology, not courage, determined the outcome, and Japanese submariners, among the bravest and most skilled in the world, died by the hundreds without ever understanding why their training and tactics had become worthless against an enemy who could turn sound into sight. If this story of technological dominance in submarine warfare surprised you, you need to see what else we've uncovered from World War II's hidden histories. We've got dozens more stories like this, the weapons, technologies, and systematic advantages that actually won the war, not through battlefield heroics alone, but through American industrial innovation and scientific advancement. Hit that subscribe button right now and ring the notification bell so you never miss these incredible true stories. We're releasing new content every week that reveals the real secrets of how American technology and production defeated Axis powers, who believed tactical excellence would be enough. Drop a comment below telling us what surprised you most about this story. Was it the loss rates? The fact that Japanese submariners never knew what sonar was? The psychological impact of fighting an invisible enemy with an unstoppable weapon? Subscribe to War Rewind, where we dig deeper into the real stories of how American innovation changed warfare forever, one technological breakthrough at a time. See you in the next video.